I integrate sine x again? I've forgotten. Negative cos x. Yes. So I've integrated it. Don't need the plus c anymore. We discussed that yesterday. 2 pi and 0 here and here is the next step. My bounds are there. And then I sub in my bounds. So I get negative cosine 2 pi is one answer, minus cosine 0. Yeah?
Yeah.
What's cosine? Oh, geez. What's cosine 2 pi? Yeah. Cosine 2 pi, yeah, it's going to be over here. It's going to be 1, and then it's going to be minus 1. Yes?
Yep.
Minus, and what's...
Wait, no, it should be 1, because minus.
Yeah. Huh?
Oh, wait, no, yeah.
I haven't got there yet. What's cosine 0?
1.
So it's minus 1?
So it's plus 1. So 0. So it's 0.
So there's no area. Oh, that's cool. There's no area under this. There's nothing. There's no area under this curve.
Well, it's a circle.
It's not a circle, it's a sine graph.
Can they cancel out?
What?
I thought it was a circle. Yeah, I actually didn't know that.
All right, well, okay, well, let's do the other one. Let's do it just up to pi. It's the same thing, yeah, so just do it quickly. Cosine x pi 0 minus cosine pi minus cosine 0. So I'm doing the same thing. I'm just doing it up to pi. Just see what the area was up to that. So that's minus cosine pi. That's isn't that positive 1 this time? That's positive 1 this time. And that's still minus 1. Oh, that's plus 1. Oh, it's 2. How's that possible?
Because it's just this part of the thing.
Well, this is 0 pi and this is 2 pi. So they're saying there's no area. This is 2 and then there's no area.
It cancels it out because this is in
Because it's in negative, the
that's
other
the
part.
negative.
Yes. So if I were to do from pi to 2 pi of sine function, what would we get?
0, negative. Oh wait, pi to 2 pi negative 2?
So from 2 pi to pi of the same thing, what will I get? That's my answer. Predictions. Negative 2.
I got
Negative 1. Okay, well, let's do it. It's the same thing again. Negative cosine x and 2 pi and pi. Sub it in. Minus cosine of 2 pi minus cosine of pi. Oh my goodness. Minus cosine 2 pi is?
1. So minus 1.
Negative 1.
Negative 1.
That's negative 1. And that's minus now what? Minus cosine pi. Well, cosine pi is over here, so that's minus 1, isn't it?
Yeah,
So it's going to be,
plus 1. Like, it's minus 1.
that's going to be a minus 1 here, yeah?
What?
No?
Yeah.
Lots of minuses.
Plus 1 minus. So it's
I
minus
think
2.
that is minus 2, the answer.
So there's okay.
So what have we learned? There's negative areas, yes. What does that mean?
That means if negative length.
That means you have to be, when is it negative area? Yeah, so when it's below the axis, we get a negative area. When it's above the axis, we get a positive area. And that, if we think about back to yesterday, if we went with the f prime of x, it's possible to get negatives because you're looking at this, it's a distance here on the y-axis. Remember that from yesterday? So the distance could just be the other way, you just get a negative. There's less. But how do we deal with that then? Like that's an issue. Because if I want the area under the curve from here to here, I kind of want the answer to be 4. I don't want the answer to be 0.
So, absolute value.
Yeah. So if you have a calculator, yeah, it's absolute value. So you can try it on your calculator now. If you do the absolute value, it will take the any negative answer and make it positive. What happens if we didn't have the absolute value? Well, if it's a non-calculator.
You just do it. Square. I don't know.
Oh, if we didn't have a calculator?
Yeah, if you didn't have a calculator, like this is what we did without a calculator at the start.
We would just take the boundaries between 0 and pi and then subtract the negative boundaries.
But
Yeah.
wouldn't we just times the 0 to pi by 2?
Yeah, you could if you knew the shape of the graph, if you were very sure of the shape of the graph. But at the start, we didn't even think about that. We just integrated, we subbed in, we get the answer 0. There's no 4 anywhere here that you can just, there's no even 2 2s anywhere here that you can add together.
Get 0, you just know it's wrong, so you have to go.
Yeah, you have to be aware of shapes of functions and probably have to be, they won't like surprise you as much as this. Sometimes they can be a bit tricky about that, but you got to recognize that if a graph ever dips under the x-axis, it's going to have a negative area. There's ways of dealing with that as well. If you know it's going to be negative, you can put a negative in front here to kind of undo it if it's underneath. But just in general, I think noticing that the answer is negative and knowing that that means it's underneath. If you ever get an answer of 0 or something like that, or a negative answer where you thought it should be positive, then you might have to look at what the graph looks like.
So you always have to take the absolute value.
If it's a calculator question, take the absolute value. If it's a non-calculator question, then you're going to have to think about the graph. Yeah.
So they won't ever ask you to calculate the area, like subtract.
Yes, they will ask you to subtract. Yeah. So it might be a cubic function or something like that, and it might be implicit in the question. So if they say the cubic function has 3x zeros, and they give you the zeros, and you think, how can I have 3 zeros? As in, a cubic function, how could I have 3 zeros without going through the x-axis 3 times? And for it to go through the x-axis 3 times, it must have gone above and then below the x-axis. And you have to figure out that this minus 1, this 1, and this 3, you'd integrate it here from minus 1 up to 1, and then you would subtract, or just do the negative of this, the integral of 3 to 1. Because this is going to be a negative answer, so you want a double negative to make it positive. Or you just do them separately, and then change it to positive and add together. So that's how it would come up.
So the question would always want you to include all areas as possible. Below or under.
Yes, the area should be positive here, because it's an area. But it just because the calculation method, which goes up to f prime of x, which could have a distance between here and here, you might have these the wrong way around, that it could get a negative answer because you're subtracting that. Remember we had the example yesterday, 130 to 80. Well, what happens if it was the other way around, the answers? Then you would get the opposite effect, yeah.
Can we, or like, would they ask us to integrate like an absolute value on our own, no calculator? Or like, would it only be?
You would like to integrate absolute value on your own, you would have to manually just do what we did there. You wouldn't.
just can't.
Yeah, you can't. Because if absolute value was written here and you got to this point, at what stage would 4 come out of this answer? Nothing. So you would have had to split it up into its bounds up to pi. So that's just a little reminder. For now, any questions that's going to come up might be slightly obvious that it's going to be split up like that. Let's look at another question here that doesn't give us any bounds. So we have this y is equal to x squared. What's that? Minus 2x. Here's quadratic, and want the area bounded by the x-axis. Thoughts?
Find the x-intercept?
Yes. What shape has this curve got? Okay. Is a happy face or sad face?
The first happy face.
No, I'm doing the second one now. I didn't do this one. Because we talked about sine x. Sine 2x can be very similar. Just a half of sine. Happy face, does it go through 0, 0?
Yes. What? Yeah, it does.
Doesn't negative 2x move it down?
Yeah, so it would, no, there's no intercept.
Goes left. Goes right. I don't know.
No, it goes, what?
Goes up.
It definitely goes through 0, 0, doesn't it? You can test the point. If x is 0, what's y?
Zero.
Or you know at the end, if there's a constant here, that's where it goes. Remember the constant? Yeah, okay. So it's something like this. Oh, that's terrible. I missed. Oh, my God. Right, something like that. There's the xy axis. So I need to know, first of all, tell me something about the area. It's going to be a negative answer. But I need to know what here and here is to find it. How do I get that again?
You equal it to 0.
Yes, equal it to 0, x squared minus 2x. So what are my two answers here?
X is 0 and x is 2.
Yeah. We knew x was 0 anyway, so that's my bounds 2, 0, that is 0, that is 2. Integrate this, then it becomes quite a straightforward question. You can do this. I don't need to finish that one. What about this last one? Find the area of, so that's done. Well, it's not done, but you could do it. So there's y is x plus 2. Two functions now. Y is x squared plus x minus 2, is that right? All right. How are we going to get the area between these two, enclosed by?
Can we factorize it to see for x plus 2? Is in the second equation?
Yeah.
Or is that not useful?
You could. I don't think it is. I think it's going to be minus 2 in the brackets.
Equal them to each other.
Equal them to each other?
Like find the points where those curves intersect.
That's a good idea. It's a really good idea. What will that help? How will that help us?
Because that will tell us
Oh,
where they're together.
okay. I think a little sketch will help, and then we can talk about a little bit more how we'd get the area of the two.
Would that be non-calc?
This would be non-calc, yeah. X plus 2, let's say this is 2. X plus 2 goes up, it's this line, isn't it? Something like that. That's the 2. And the other one, happy face, parabola, goes through minus 2, yeah. Is that then the vertex?
No. E squared minus.
Yes,
minus b
because
minus
there's
c.
no other numbers, right? Minus b over 2a.
It is?
Minus b over.
Oh, we can check, yeah. So minus b over 2a should give me the axis symmetry. So what's
That'll be 1/2, negative 1/2.
minus
1,
1 all over
2.
2? Okay.
Yeah, at least I had the minus b over 2.
So it gets the x value. The x value of the axis symmetry is slightly over here, somewhere here. So the u will be at its bottom here, yeah? It's coming back up.
X minus 2, x plus 2, x minus 2.
So factorizing this would definitely be helpful for me drawing it. 2, 1, minus plus. So that means it crosses at minus.
What? No. X plus 2 is minus.
Thank you. There you go. It does factorize. X plus 2, so it is x plus 1 here.
Oh, it intersects at that point.
Intersects here?
Yeah.
You sure?
Yeah.
You sure this is 2?
Wait, when x is 0.
When x is 0, y is 2? When x is 0?
When y is 0.
When y is 0, x is minus 2.
Yeah.
Okay, when y is 0, okay, so it does double cross over here. And it crosses over at 1 here. All right, so now we have a visual. It's looking for the area between the two. That's not a great curve, but it's looking for the area between the two. It's kind of sad looking. That area, fantastic. And we know that this point here is minus 2. Am I right? Yeah, minus 2. And this point here, don't know.
So there's a.
Will we find there?
No, you be quiet. Aiden knows how to do it. I want people to struggle with know how to do it first.
Is it on your wall? Oh. Well, watch.
No, don't look at the wall.
Oh, like, think about it.
Think about it. I think knowing this point would be a good idea. Yeah.
Guys, equal that.
Let them equal. As Priyanka said this at the start. X squared plus x minus 2.
Why would we just use the factorization to equal 1 equals
Yeah, and then
x
x
minus
plus 2 over x plus 2 is 1.
Yeah.
Skaters are my idea.
Hmm?
You guys actually gave me.
Am I right here?
It's good. What? Ain't nobody.
So x is equal to plus or minus 2.
Yep.
Okay, we knew minus 2 already. That's great. So the other one's plus 2. Fantastic. So this is 2. The x value here is 2.
Oh,
And y is 4.
If you really
That
think
line
about
is
it.
beautiful.
can I suggest something?
Yes, absolutely.
If we find the bottom of the other curve,
Here?
yeah, that curve from 1 to 2, and we minus it from the y equals x plus 2, would that work? That's just a long way of doing
What
it.
we just
Minus it?
add the integration of the x squared plus x minus 2 between negative 2 and 1. And
Okay.
then add that to the integration of x plus 2 between negative 2 and 2.
But what you should subtract.
Subtract what?
Oh, yeah, subtract
Top
Why?
subtract bottom because bottom is negative.
Okay. Yeah, that's definitely a way of doing it, yeah. So what we could do, so you're suggesting, Derek, that we take the line and we get this area, yeah? Am I right in saying that? And then add to that area which part of the parabola? This part?
Yeah, and then minus the
Uh,
bottom area from.
So we have this part from that. Wouldn't that include this part?
Yeah, we can minus that.
How will we minus that area?
1 to 2.
Oh, so you get from 1 to 2. Oh, that would work, yeah.
It's a lot of effort. Yeah, it's like too much.
Wait, what are you guys?
No, it's a good idea. So get the area here, get the area under there, and then subtract this area. You get that separately. Get this area separately from 1 to 2 here. Wouldn't that work?
So, yeah.
It's so much work, yeah, but we got no other suggestions, Aiden.
If your pause has a sentence.
No, I don't have any suggestion. Would it be easier if these two were not, under the axis and stuff like that? Would it be easier if they were floating up here in space and you had it like this? Would that be easier?
So you translate it, yeah.
I mean,
I haven't put this in the same spot, but just in general, yeah. If we translated them up, would it be easier?
I did, no.
it
Uh,
would just subtract.
Oh yeah, I find it.
Yeah. So you'd find the area under the line,
And subtract.
and then you'd subtract the area at the same bounds under the. Yeah. So if I move both these up, let's say I move them up 10.
Really, you only have to move it up by half because these don't work.
Yeah, I could move it up by half is the x value, but the y value, whatever it is, I think it's more than that. If I just moved it up, made sure it was above the x-axis, be no problem. Yep. Would I get the same area if I just moved sliding both up? Yep. Okay. How would that affect my answer here? Would I get?
No, you wouldn't.
Well, how?
If you found the area under, let's say -2 to 2, it would also find the area of what you lifted.
Mm.
So,
The area of what you lifted.
like, let's say you move it up 3, right?
Yeah.
You would have a 3 by 4 area, so you need to minus 12 from that.
Okay. Let's think about it. Right. Let's just make absolutely sure they're above the x-axis. What is this? Did you find the y value of this point?
Sudden negative.
Negative a half into the. Oh, just give me an estimate. That's a quarter plus a half minus 2. So it's around.
Negative or half?
A quarter. Wait, quarter plus a half.
It's -1.
Minus a half.
Okay.
1.25.
Let's just add. I'll go with my idea. Add 10. We know that they're both going to be above. They'll be the same shape. They'll both be way up there. Add 10. Aiden gives me the look. Because Aiden learned off the formula. He doesn't really know why.
It's like,
But I'm adding 10 to both. I'm going to get the same. So now instead of y plus 2, y is equal to x plus 2. That's now moved up 10. How do I move it up 10? X plus 12 now. Okay. And instead of y is equal to x squared plus x minus 2, we get y is equal to x squared plus x plus 8. Okay. Right. So now if I integrate these two and subtract the two answers, I should get like the translated area, which should be the same as this area. No?
Mr. Pons, did you just equal them to each other?
I did not.
So where did the 8 come from? Oh, you
I added 10. I added 10 to both. Just move them up 10. Sounds good to me. Move them up 10. So integrate x plus 12 between, what my bounds going to be again? Yeah, what were they?
2 and 2.
Minus 2, yeah. 2 to minus 2. And to that answer, I'm going to, well, which ones should I subtract? Which one's going to give the,
Which one's going to give the biggest?
I should put this one and subtract the curve to get, I'm looking for this area, remember? So the one on top is the line, yeah?
Yeah.
And I subtract the one below because I don't want the I want the area between them. I don't want this area, do I? No. Okay, so I'll have to subtract the 2 minus 2x squared plus 8 plus 8. Okay, so integrate these. I'll try and do it quite quick. X over 2 plus 12x, yeah? Between 2 and minus 2. Possibly could have picked easier number instead of 10, but okay. So integrate this x cubed over 3 plus x squared over 2 plus 8x 2 minus 2. And now I got to sub everything in and get an answer. Oh my goodness. That's a lot of substitution.
2 plus 24.
Yeah, 2 plus 24 is correct.
2 minus 24.
Minus 2 minus 24. We happy with that?
Yeah.
Okay, that's not going to be too bad.
So many brackets.
So many brackets, yeah. 8 over 3. Oh, we're going to write this out. 8 over 3 plus 4 over 2 plus 16 minus minus 8 over 3 plus 4 over 2 minus 16. This is where mistake-free maths is useful. That is a lot going on. All right, give me an answer here. 26.
Or 22.
26 minus 22.
So plus 22.
Yes.
Yes.
So 48.
60. 60. A 70. What? I thought we went plus 20.
26 minus
Oh,
minus
sorry,
22.
sorry.
48. Okay, that's 48. So the area from here down is 48. That's this area. And now I'm going to subtract whatever this other thing is. 8 over 3. Jeez Louise. 8 over 3.
Plus 18.
So it's 16 over 3 anyway. These two. Because that's a minus. 4 over 2. These cancel, don't they?
Yeah.
And 16 minus minus plus 32. So that's 32 plus 16 over 3.
What?
No?
Wait, where did 16 over 3 come from?
8 over 3 minus minus 8 over 3.
Oh, I thought it was a plus.
I know, yeah, that's a permanent stain on the board. That's a minus. Okay, now I know it's 48 minus this. So that's going to be 12 minus 16 over 3. So I did the 48 minus. We're trying to do this as fast as possible. So what's these two subtracted?
36 minus 16, 20 over 3.
20 by 3.
20 over 3? Now, the question is, did the 10 up matter?
No.
No.
Could I have done it just with these two equations?
No. In theory.
Yes, it just would have taken you a lot more.
With the same two equations? Not your method, just using this
It's
method.
absolute value.
So what I did here was I got the one that was on top, and I took away the one that was on the bottom.
I thought you meant we are like part
For that one,
No, would it not?
No, because part of it is under there.
So no, because it's got to count the areas for that little triangle thing between 1 and 2.
Mm.
If you do that, if you did that for 1 and 1.
What happens if I get the area between 2 and minus 2 of this one? What would happen?
Of the top?
Of
What would happen these two areas?
Yeah, both of them would be accounted for.
Yeah,
But we don't want
but this is below.
Yeah.
Oh, well, I feel like we might as well just do it and see what answer we get. If we just do nothing and just do the same as this, do we get the same answer? And if we don't get the same answer, the one on top is x plus 2. And I'm going to subtract the one on bottom, which was 2. Yeah, Derek's given up.
He's not happy.
X squared plus x. I think that the fractions are going to be annoying again, but you get to it. 2x, 2 minus 2 minus, should use square brackets here, I didn't. Tell me if I'm wrong doing something.
Seems right.
Seems right. 2 minus 2. Trying to do it faster. So that's going to be 2 plus 4?
Yeah, no, 2 plus, yeah.
Yeah. Minus 2 minus 4. Yes, I know. Why did we stop doing this one? Because we finished it. We got an answer. This is 20 over 3. This one now is minus. Oh, jeez. We get the 8 over 3s again, which are our favorite. Minus 4 minus 8 over 3.
Plus 4 by 2. Plus 4.
He's just taking a break.
I'm just taking a break, yeah.
Look at
Breathe.
it all go tilted.
Yeah, plus 4 over 2 again, yes.
Plus
And
4.
plus 4. Yes?
Yeah.
Okay. This goes with this, because it's minus. 8 over 3.
Minus 16 over 3.
Well, it becomes a positive, so won't it go like? No, it's negative.
I think that should be negative. I didn't put that in. Yeah, my mistake. So it's 16 over 3 again, isn't it? Let's tidy this. Let's do this one first. It's easier. This is 6, 8. Minus 16 over 3 again pops up. These cancel. And no, it's minus.
4 minus 4.
But then
Minus
there's a
eight.
negative there, so won't it become positive? What about the negative in between in between your two brackets?
Yeah. Minus.
So that one.
Yeah, that one negative.
Right, this is minus, this is minus, this is minus. Okay, let's just deal with these minuses first. Minus 4 is minus 8. Yes, this minus is still out here. Yeah?
So how do we get 16 by 8?
By 3, that's
All right, this is 8 then, minus 16 over 3 plus 8, which is 8 plus 8 is 16.
16 minus
Yeah.
16,
48 minus 16, 32 over 3.
32 over 3. It is a different answer.
Oh, is it?
Was it
Wait,
not
that's
supposed to be?
weird.
That's not supposed to be.
Of course not. Where did we make the mistake?
Is it so? Wait, it was definitely your fault.
Is it supposed to be? Is it not supposed to be?
That's what we're asking you.
No, it's not supposed to be. So we made a mistake.
It's wait.
It's
what do you
not
mean?
supposed to be.
It's supposed to equal 20 by 3.
Either it's supposed to equal this or this. That's where we.
Oh, nice. So we don't even know which
So
one's
one
the
counts.
answer.
That's what I'm saying. 8 by 3 doesn't equal to 16 by 8. 8 by 3's cancel out.
What 8 by 3? Yeah, it does because minus 2 cubed is minus.
Wait, 8 by 3
No,
minus
2
8 by
cubed by
3.
3 is 8 by 3.
Wait,
Yeah, and then the other one
8 by
is
3
minus
plus
8 by 3. 8 by
Minus.
3.
Oh, yeah.
no, that's still.
No.
Wait, maybe we should check our working for the other one.
There is a quicker way still, but
And why would you give it to us?
I want to do the slow way.
Wait, the answers are not. How are they supposed to be equal though? Because you're accounting for that triangle at the right.
But don't we account for that anyway? Because if we get integrate between here and here, I made him, yeah.
Wait,
Because if we do top minus bottom, we would only get that triangle, that whole triangle, and that, but we wouldn't. I don't know. How to, like I could just show it, but I don't know.
As in, this is the problem.
Yes.
ooh.
What's the problem?
Because there's like a definite
Because that area is positive.
Is that
and
area
one,
12 by
that
3?
area is negative.
This area is negative.
Yeah.
When I get the area between here and here on the U-shaped curve, what area do I end up with?
Right.
Oh, is it a triangle? It's not a triangle.
No,
Mm.
you don't, we haven't,
I thought we already
we
said
need to minus it, we need to minus it.
We already got- We kind of got that area here. It's a negative area. There's more below than there is above.
Okay, wait, then.
No, but I'm saying that if you have that big triangle, subtract the negative area, you would get
I
them
see it.
added together, but we're including that area that's not supposed to be there. That's what I'm saying.
Yeah.
Yeah.
It's not meant to be, it's not meant
That's
to be
not
8,
included.
it's not meant to be 8. Because
It's not meant to be 8.
well, the first value is 8, right? The area of the top triangle is 8, because you can do that without it. It's 4 times 4 divided by 2, 8. But it's not meant to be 8, because we haven't subtracted the right part.
Yeah, see, that's what I'm saying.
Yeah.
Like
So-
that, the one you
So
should
we
include,
need to-
it's not supposed to be there. That's why you have to use a formula.
But when I get the area between when I get the area between here and here. So if I draw that again, let's say there and there. This and this, wouldn't this subtract from this?
Whatever you want.
I don't know.
We don't.
I can't provide.
Oh yeah, I
It's
said
the same
correctly.
with sine.
Yeah, I said correctly.
So I think we made a mathematical area. Do you see what I mean?
Yeah.
When we get the area between these two bounds, this is going to be negative and this is going to be positive, and they're going to end up subtracting this bit anyway.
So then cancel it out. So what's wrong? Let's figure out what's wrong.
Well, there is a quicker method, but I think
Okay, but stop with the but. There is a quicker method, and so like what?
Where was
Why
this
can't we just like
beneficial?
go?
Where
Hmm?
did it go
Instead
wrong?
of doing like f of x, y, z there.
what's what?
But where would be like having two separate boundaries be like better?
No, I'm not saying it's better. What I'm saying is there is a quicker method, which I'm going to tell you now because we're running out of time.
Class is taking 4 years off my life.
I know, well, it's good to think about it. It's good to think about it.
No, but I want to know. I want to know what we did wrong.
Oh, yes, okay.
So it's
It might be this one. It mightn't be this one. It might be this one.
It's supposed to be the same.
Yeah.
I'll check the answer. Maybe that'll make it.
No.
I'll check the answer just to see which one is wrong. Which one's wrong, and then we find why we got it wrong. One of them's right, surely.
It's more rewarding if we actually find out.
It's just a.
But
Because it's not our mistake. It's Mr.
Screw the band-aid off.
It's definitely my mistake, yeah. But I'm trying to figure out where.
minus 8. Okay. What if neither of them are right?
Well, that will be annoying. The answer is 32 over 3. So the one on the right is wrong.
Wait. Okay.
The one on the right is the one we made a mistake.
Maybe we subtract too much off the bottom. Okay. Never mind.
Well, first of all, no.
Wait.
2 plus
No, minus.
16 by 3. That's not supposed to be there because it cancel out.
No, it doesn't.
What?
Oh, no.
Bro's just trying to find it.
Oh, is it? Maybe it's not 16 plus 32. Maybe it's 16 minus.
Oh. Plus.
No, it is plus 32 because that's 16.
But when you expand, isn't it supposed to be like 48 minus 16
Wait,
by 30
what?
minus 30? Oh, you did that. Like,
Yeah, I did,
No,
yeah.
why wouldn't it be?
It's just not 12. It's just not 12.
It's just not 12.
It's not 12.
Where did we get to 12?
Mr. Hubbard.
48.
16.
Well, that's 48 over 3, which makes this 32 over 3. Ah!
Create a round.
How did we get to 12?
Can we do it even quicker?
Yes, we can.
What?
Tell us.
Yes. When we write,
How'd you guys?
all right, when you write something like this,
3 minutes.
when you write something like this, when you integrate in general, as in if you integrate x squared,
You know what? I'm gonna mark this moment back.
And this is on
Wait, you can't cut it out of the video, sir. Please,
Right.
You have to keep it in the
oh,
video.
it's definitely gonna. There's gonna have to be a scene miss. I'm just not going in the video. If I integrate these two, right?
Yeah.
What's my answer separately?
2.
So that's
2x.
2x cubed over 3 minus x cubed over 3. And then it's x cubed over 3, yes? So I can subtract before integrate. So when I have something like this,
What?
That's intense. That's intense.
I can subtract before I integrate.
So what are you subtracting?
This and this. So I end up with integral of negative x squared
Minus x minus x.
So this-
minus 2x.
x minus x is nothing, and 2 minus minus 2 is plus 4. So I could have just done this and not have to subtract. I could have subtracted here because I get the same answer for the integral anyway, and just subbed in.
Nice.
Why have I never known that? I did my whole I'm not even doing it the wrong way.
So we could have just done this, which maybe we'll do tomorrow. Oh, we could do it. Can we do it now? What you got? Minus x cubed.
Why are we doing it again?
No, you cannot
No,
leave.
sir.
You cannot leave.
It's 10 o'clock.
Minus x cubed over 3.
It's gonna be wrong anyways.
No.
Oh, it's certainly going to be wrong because I'm rushing.
I believe in you, sir.
No. Thanks, Aiden.
8 by 3 minus 8.
That's 16, yeah?
Yeah.
Every single one of myself.
Okay,
minus two of these, minus 16 over 3. It's the same as this. Could have got it. There we go. I was going to do it 3 ways, and I did it 3 ways, but it took one mistake. One mistake ruined the whole example.
You can't come down.
Please don't forget to upload it.
I'm not uploading all that.
Okay, but you need to upload.
Oh, wait.
Maybe you should just